we are discussing linear relations. So what do we mean when we say linear relationship? If something or a value increases with the other value in a proportional manner, then we will have a straight or linear relationship between them. If it doesn't, then we may have some curve type of relationship. So we need to look at certain pattern first. So here is just a pattern of squares. So if we make the table of the perimeter and the area, see the perimeter, this is a frame number 1, the perimeter is 4, 1, 2, 3, 4. We take a unit, means a distance as 1 unit. So this is 1, 2, 3, 4. When we take frame number 2, what will be the perimeter? Boundary 1, 2, 3, 4, 5, 6, 7, 8. Similarly, if we increase up to 6, the perimeter will be 24. But when we talk about area, this is frame, so this is 1 unit. Then we have this 1, 2, 3, 3 units. 3 blocks are there. It will be 3. If you go to 4, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 4 it is 10, likewise for 6 it is 21. So the graphs of the data which we see here, in the x-axis we have given frame number, here also we have frame number, and here we have perimeter, and of course we have taken one at a time. This length is also 1 unit and the area is also 1 unit. So now the relationship, the graph of perimeter against the frame number, it's a linear relationship. That is, the point lie on a straight line. This is a straight line. If we join these points, then there will be a straight line. And if you see here the graph between the frame number and the area, this is a non-linear relationship because this is not a straight line, it's a curve. It's a curve. What I'm trying to say here is this is a complete straight line, but here it is a curve. Like this, it's a curve, and here we have a straight line. So this straight line refers to a linear relationship, and here this is not a linear relationship, though we call it as a non-linear relationship. If this is linear, we don't say this to be curve, but this is non-linear relationship. Now we are adding one more column, that is, what is the change? That is third column to record the change. That is, this is the perimeter. So what is the change here? 4 and 8. 8 minus 4 is 4. 12 minus 8 is 4. 16 minus 12 is 4. So if we take the difference of any of these two, which are consecutive, we say that we see that the change in perimeter is always 4. That is the same number. So this is for all linear relationship. They have differences that are constant. If you see, these are numbers which are constant. If you take 16 minus 12, it will be 4. If you take 24 minus 20, it will be 4. That is, all the linear relationship, they have the difference as constant. Let us take one more column in the area table. The second table we drawn a curve for frame number and area. Now here if you see the change in area, 3 minus 1 is 2, 6 minus 3 is 3, 10 minus 6 is 4. Here we have 15 minus 10 is 5 and 21 minus 15 is 6. If you see 2, 3, 4, 5, 6, all these are different. That is, they increase one at a time. It may be different, but they are not equal. That is, the area increases by certain different amount each time, but the perimeter increases about the same constant every time. We'll take an example here. The example is like this. This is a table that shows this is the amount account or amount balance, and these are the number of weeks, that is the bank account when it was opened at the end of each following week. We have to find the differences, and we have to see first differences what it represents. That is, first means just consecutive differences of the numbers which are on this column, and we have to find out whether this is showing a linear or non-linear relationship. We have to graph this relationship and also describe how the patterns in the table are shown in the graph, and how much money is in the account after 6 weeks. So this is about 4 weeks. We have to talk about 6 weeks also. So let us take the first difference, that is 175 minus 200 minus 25, 150 minus 135 minus 25, 125 minus 150 minus 25, 100 minus 125 minus 25. So the first difference shows there is a constant number. Since this graph, or you can say since these numbers are negative, that is, money is being withdrawn. So here we have a linear relationship. The first difference are equal, the relationship is also linear, only the line will be like this, that is, it will be downward trending. So these points lie on a straight line. This goes through goes down to the right, not like this which we just saw in the previous discussion. For every unit you move to the right, that means this much. To move to the right, 25 units down. And if you see the graph 50 $50 in the account after 6 weeks. So if you this is 6, just take this up and take this parallel to the number of weeks. This is 50. Here we have a graph, and this is showing the time with distance, that is the distance which is changing over a time during a trip. Now the graph is linear here. This is called a distance time graph because this is distance against time. So we have, what is the speed? Speed is always distance by time. You can take any 2 points. Say we are taking this point and this point. So what is this point? 1 and 75. X is 1 and Y is 75. This is X is 3 and Y is 225. So these are the basically coordinates of this graph, and this is coordinate, that is time comma distance, So need to find out the rise, that is the vertical distance. This is the rise and this is the rise and run. So what is the rise here? This value is 225 and this value is 75. So the rise is from here to here, it is 225. From here to here it is 75. So what will this be? 225 minus 75. Now in order to find this, what will this be? This is 3. And what will this be? This is 1. So what will this be? 3 minus 1, that is 2. So we get 150 here, and 2 is of course there. So what is the speed? Speed is distance by time. Distance here is 150, the difference, and time is 2. So we get 75. This 75 rise by run is the rate of change. That is it is measuring the steepness, that is the angle here, m. If a straight line is there, then the inclination m or tan theta, or you can say steepness of the line is shown here. So rate of change will tell you that whether it is going up, the graph is going up, or down. For every unit you move to right, if you move right, the graph is going up or it is coming down. So their rate of change of distance over time is nothing but the average speed we talked about. Let us take an example of this. So we have the example here. Natalie leaves downtown Ottawa to meet a friend at Dow's Lake, 6 kilometers away. She skates along the Rideau Canal. It takes Natalie 5 minutes to skate 1 kilometer. Now we need to assume an athlete keeps skating at this rate, that is 5 minutes to skate 1 kilometer. We have to make the table to show her distance from the downtown at 5-minute interval, graph the data, and rate of change needs to be found out, and how long it will take for her to reach Dow's Lake, and what is Natalie's average speed in kilometers per hour. So see, at 0 time, we'll make a table about that. Time 0, distance from downtown is 0. As the first thing is given that 5 minutes to skate 1 kilometer. So at 5 minutes, she will be at 1 kilometer. At 10 minutes, where she will be 2 kilometer. That is just twice. We made it twice, this will be twice. At 15, it will be 3. At 20, it will be 4. So every 5 kilometer we increase 1 kilometer. Now let us make the graph. This is time, this is distance from the downtown. So we are taking time that is from 0 to 30 say, and on the y-axis we are taking 0 to say 6. So 0 0 is this, 5 1 is this, then we have 10 2 is this, like this we make a graph, and 24 is of course 20 and 4. So we will find out the rise and run. We will take any 2 points. So we can take any 2 points, say this, we are taking the point as this one, this is 5 1, and this one we are taking as 24, that is this point 5 1 and 24, that is this point and this point. So what is this point? This is 5 comma 1, oh sorry, this is 20 comma 4, and this is 5 comma 1. So we'll find out the rise and run. What will be the rise? Rise will be 4 minus 1. So 4 minus 1 will be rise. And what will be the run? It will be 20 minus 5. So 20 minus 5 like this. So this will be 3 by 15. So 3 5s are 15. That is coming to be 0.2 kilometer per minute. So this is the rate of change, that is 0.2 kilometer per minute. This is the Nathley's average speed in kilometers per minute. If you want to extend the graph, we can see that it takes Nathley 30 minutes to travel to 6 kilometers. So just 6 kilometer. If you take this one 30, you'll get 6 kilometers. So this is the 6 kilometer value. And since average speed is 0.2 kilometer per minute, so in there are 60 minutes in 1 hour. So 0.2 kilometer in kilometer hour per hour. So this is 1 minute. So we know in 1 hour we have 60 minutes. So for 1 minute we can write 1 by 60 hour. So 0.2 kilometer by 1 minute. 1 minute I am writing it as 1 by 60 hour. So 1 by 60 hour. So I am taking 60 up. So I have to multiply 60 and 0.2. This would be 12 kilometer. This kilometer an hour. 12 kilometer an hour will be the speed. Now this graph is showing the average fuel efficiency for an older SUV and new smart car. So we have these graphs. So the rate of change, how we can find out for each vehicle? We can just take any 2 points on smart car linear relation and SUV relation, any 2 points. So we are taking in smart car 50, 15 and 360, and 5 and 120. Here SUV we are taking 20 and 180 and 10 and 90. So we need to find out the rise and run. So the rise and run can be found out using simple thing what we have done in the earlier discussion. That is this one. I am taking the smart car first. Smart car. So 360 minus 120 will be rise and 15 minus 5 will be run. Just divide them. That is 240 by 10. That is 24 kilometer per liter. Let us go to the smart car. Sports car. Sports car 180 minus 90 will be the rise and 20 minus 10 will be the run. So just divide it 90 by 10, that is 9 kilometer per liter. This is 24, this is 9. So the sport utility vehicle, it drives 9 kilometer for every liter of fuel it uses, and both the rate of change, if you see, they are positive. And the more efficient car has a greater rate of change and a steeper line on the graph. Okay, so more efficient car is what? The smart car. So it has more, say, steepness, and this is the more for distance. It is the volume of fuel is used is like this. So this is showing it 24 kilometer in a liter. This is just 9 kilometer in a liter. So this is more efficient. So the steepness of this red line, that is the more efficient, has a greater rate of change. If you see here, that is 24, and steeper line on the graph, more steeper. The angle is more. If I can tell you about the angle, this angle is more than this angle. The rate of change can be negative. Let us take an example of negative rate of change. So this graph shows how the height, this is the height of a small plane, changes with the time. So what is the plane initial height? Determine the rate of change, and what does the rate of change tell you about the plane's flight? So the plane initial height is 1800. Now it is coming down. It is coming down. We'll see when it touches 0. So we'll take any 2 points. This is 18, x is 0 and y is 1800, and we can take any other point like this 4 1. This is 4 and 1200. Now let us try to find out the rise and run. So the rise will be 1200 minus 1800, that is minus 600, and run will be 4 minus 0, that is 4. So minus 600 by 4, that is minus 50 meter per minute. This is the rate of change, it is negative. So the height, if you see, it is coming down. The plane is about to land, so height is decreasing at an average rate of 150 meter per minute. So the plane is descending. Okay, let us see about Rhonda. Rhonda bought sesame snacks at the bulk food store. Now the cost was $1.1 per 100 gram. So this is a table showing this. So this is the mass of sesame snack and this is cost. So 2.20, it is 200. For 400 it is 4.40. For 600 it is 6.60. So the graph, if we want to draw the graph of this is the mass, this is cost. So you see that the graph is a straight line that passes through origin, and this is a direct variation. That is the cost, this cost varies exactly or directly as the mass does. So when they vary directly, we call them as proportional. The cost is directly proportional to the mass. These are directly proportional. That is why we have a straight line. So we can find out the rate of change. Take any 2 point. That is, I am taking this one, 600 and 6.0 and 200 and 2.0. So what is the rise? 6.0 minus 2.0, that is 4.40. And then we find out the run, that is 600 minus 200, that is 400. Divide them, we get 0.0111 per gram. This is the rate of change. So the rate of change is the unit price of sesame snacks, 0.011 gram. And if you want to find out the cost of sesame snack, you just multiply this rate of change with mass of snack. So if you have say 350 gram, because this is the mass which is not given, in between if you want to find out say 350, so just multiply 350 with this, that is rate of change. So just multiply 350 with 0.011, that will be 3.85. So you can find out intermediate values also. Let us take an example of that. So gas for a car is sold by the liter. So here we have a cost and volume as table. 5 customer observations are here. We have to graph the table, and does the graph represent direct variation, and we have to determine the rate of change, what it represents, and write an equation of the relationship and use the equation to determine the cost of 25.8 liter of gas. So we'll make the graph, we'll take volume here and cost here. This is the graph which will form. So this is a graph which is representing a direct variation. The graph is linear, it also passes through origin. So any graph which passes through origin, then only we can say it is having a direct variation. So let us take any 2 points. This is 5.10 and this is 15.30. So what is the rise? 15.30 minus 5.10. What is the run? This one, 18 minus 6. So we have 10.20 by this 12. So rise by run is 10.20 by 12. So this is the rate of change. So this is 0.85. So in order to find out the cost of buying a gas, this cost of gas is simply, you just multiply the unit price, this is the unit price, with the volume. This is the equation of the relationship, just 0.85 into the volume in liter. So if we have a volume of 2.25.8, just multiply 0.85 by 25.8 liter, you will get the cost as $21.93. The cost of a pizza with tomato sauce and cheese is this $9. So it costs 0.75 for each additional topping. So this is the table showing the cost of pizza with up to 8 additional toppings. So we have 0 toppings, it is 9, 2, 10.50. So the cost in dollars for 4 topping is given by this 9 plus 4 into the cost of 1 topping, that is, let me show you. 9 is the basic cost. So if we have say 1 topping, it will be 0.5 for 1 topping. So this is the cost. If you have 2 toppings, just take 2. If we have say 10 toppings, it will be 10 into 0.75. This will be the cost. So this is a relationship which we can make. So points are joined with a broken line here. If you see, we cannot order the fraction of toppings. We just have to order these are in numbers. Now this line, the point line, a straight line, the graph does not pass through the origin. That is, this is not a direct variation. It is a partial variation. So the cost of pizza is the sum of what? Fixed cost, as we saw, fixed cost and variable cost. So the point where the line crosses the vertical axis, that is this is the vertical intercept. This is the vertical intercept. So here vertical intercept should be 9, and it is 9 actually. So it represents the cost of pizza with 0 toppings. So what is the, if you want to find out the rate of change, or you can say rise and run, take any 2 points. So we are taking points, say 12 and this, say 4 and 12. Here we are taking 4 and 12, this point, and this point is 2 and 10.4 is 50. So what is the rise? 12 minus 10.5, and run is 4 toppings minus 2 toppings. So 1.50 by 2 will be the rate of change. So this rate of change is equal to the cost per topping, which is 0.75 per topping. So cost of pizza, as we say, just found out that this has to be and this goes on for various applied things also. This is the basic cost, this is number of topping, just multiply it with the basic cost, you will get the cost of pizza. So if we have C represent the cost in dollar, N represent the number of toppings, this is the vertical intercept, that is the basic cost, and this is the rate of change multiplied by N. This is the general formula if you want to write an equation. So Jolanda has a window cleaning service. She charges $12 fixed cost, that is 12 is the fixed cost, plus 1.50 per window. So say if we have n window, and this is the 1.50 per window. So this is the relationship which we are talking about. Write an equation to determine the cost when the number of windows cleaned is known. And what does Jolanda charged to clean 11 windows? So as I just said here, this is the equation. The cost is 12 plus 1.50, that is 12 plus 1.50 into the number of windows. So if C is representing the cost in dollars, N is representing the number of windows, so the equation will be 12 plus 1.50 into 9, N. And we have to use this relationship to find out for 11 windows, just put 11 in the place of N. 1.50 into 11, that is 16.50, added with 12, it will be 28.50. 28.50 is the cost for cleaning 11 windows. So this is the first part of our discussion. We'll be taking one more part shortly. Till then, thank you so much. Take care of yourself.